It's another exciting time with chemistry. We are looking at the topic today, laws of chemical combination. There are 4 laws of chemical combination. Although these laws have been proved to be slightly incorrect, yet they still form the main basis of modern chemistry. The 4 laws of chemical combination, which describe the general features of a chemical change, have been proved to be only slightly correct. They still form the basis of chemistry. Let's consider the laws one after the other. Let's consider the laws of chemical combination one after the other. 1. The law of conservation of mass. It states that matter is neither created nor destroyed during chemical reaction, but changes from one form to another. That is to say, you cannot create matter, neither can you destroy matter during the course of chemical reaction. The second law of chemical combination, that is the law of definite proportion or constant composition, states that all pure samples of the same chemical compound contain the same element combined in the same proportion by mass. Number 3, the law of multiple proportion states that if 2 elements, A and B, combine to form more than one compound, then the various masses of one element, A, which combine separately with a fixed mass of the other element, B, are in a simple multiple ratio. Number 4, the law of reciprocal proportion states that the mass of several elements, A, B, C, which combine separately with a fixed mass of another element, D, are the same as or simple multiples of the masses in which A, B, C themselves combine with one another. Example 1. 2.85 grams of an oxide of copper gave 2.52 grams of copper on reduction, and 1.90 grams of another oxide gave 1.52 grams of copper on reduction. The data above illustrate the law of A, constant composition, B, conservation of mass, C, reciprocal proportion, D, multiple proportion. Let's solve the problem so as to obtain the appropriate solution. Mass of first oxide. (2.85 grams). Mass of copper contained in it, 2.52 grams. So therefore, mass of oxygen is 2.85 minus 2.52, giving us 0.33 grams. It implies that 2.52 grams of copper combined with 0.33 grams of oxygen. Therefore, let's take a fixed mass of 100 grams. 100 grams of copper combined with 0.33 divided by 2.52 multiplied by 100. This gives us 13.09 grams. This for the first oxide. Let's consider the second oxide. Mass of second oxide is 1.90 grams. Mass of copper contained in the second oxide is 1.52 grams. Therefore, mass of oxygen contained in the second oxide is 1.90 minus 1.52, giving us 0.38. That is to say, 1.52 grams of copper combined with 0.38 grams of oxygen. Therefore, we are considering a fixed mass of 100 grams. Therefore, 100 grams of copper combined with 0.38 divided by 1.52 multiplied by 100. This gets us 25. And so the masses of oxygen that combine with a fixed mass of copper, 100 grams in the two cases, are 13.09 to 25. And that is 1 to 2. Now it can be seen that the masses of oxygen that combine with a fixed mass of copper in the two cases are in agreement with the ratio 1 to 2, which implies the law of multiple proportion. The law states that when two elements A and B combine together to form more than one compound, then the various masses of A, which separately combine with a fixed mass of B, are in a simple ratio. Like we can see here, 1 to 2 is a simple ratio. And consequently, the correct answer is B. These data are in agreement with the law of multiple proportion. Let's try to enhance our understanding by considering a second example. A mixture of 12 grams of carbon and 32 grams of oxygen are heated until the reaction is complete, and none of the reactant is left over. What mass of the compound carbon 4 oxide is formed, given the relative atomic masses of carbon to be 12 and oxygen to be 16? Well, the options are A, 44 grams, B, 40 grams, C, 4.4 grams, and D, 45 grams. Let's see what the correct option is. Equation of reaction is carbon plus oxygen gives us carbon 4 oxide. Now, mass of carbon is 12 grams. Molar mass of carbon is equally 12. Therefore, number of moles is mass in grams divided by molar mass. (12 over 12), which is 1. Consequently, mass of oxygen is 32 grams. Molar mass of oxygen is equally 32. Therefore, number of moles is mass in grams divided by molar mass, which is 32 over 32, which is 1. From the balanced equation, the number of mole of carbon 4 oxide is 1. Number of mole of CO2 is 1. Therefore, mass of CO2 is 12 plus 32, which is 44 grams. So the mass of the product, that is carbon 4 oxide, is 44 grams. Let's now refer to our options. The first option, A, is 44 grams, B is 40 grams, C is 4.4 grams, D is 45 grams. And consequently, the correct option is A. Let's consider the third illustrative examples. If 6.0 grams of carbon is heated in air, the mass of the product obtained could be either 22.0 or 14.0 grams, depending on the amount of air present. With what law will this be in accordance? Then we are given the relative atomic mass of carbon to be 12 and oxygen to be 16. Now the options are A, definite proportion, B, conservation of mass, C, multiple proportion, D, reciprocal proportion. Let's solve the problem so that we can come out with the correct option. The reaction is between carbon and oxygen to give carbon 4 oxide in the two cases. So let's start from case 1. Mass of first oxide is 22 grams. Mass of carbon is 6 grams. So to obtain the mass of oxygen, we simply subtract. So mass of oxygen is 22 minus 6, giving us 18 grams. Let's consider the second oxide. Mass of second oxide is 14.0 grams. Mass of carbon is 6.0 grams. Therefore, mass of oxygen is 14 minus 6, giving us 8 grams. Now, when you look at the two oxides, the masses of oxygen that combine with a fixed mass of carbon in the two cases are in the ratio 18 to 8. Masses of oxygen that combine with a fixed mass of carbon, i.e. 6 grams, are in the ratio 16 to 8. So apparently 16 grams, 22 minus 6 is 16 grams. And so if you divide by the smaller, 16 divided by 8, 8 divided by 8, giving you 2 to 1. So 2 to 1 is a simple ratio. Let's now turn to the options. It can be seen that the masses of oxygen that combine with a fixed mass of copper in the two cases are in the ratio 2 to 1. That is, the data is in compliance with the law of multiple proportions. Consequently, the options are A, definite proportion, B, conservation of mass, C, multiple proportion, D, reciprocal proportion. Consequently, the correct option is